Welcome to this ACU Mathcast. In this episode, we're going to be looking at some of the foundations for permutations, specifically some of the notation and concepts involved. Let's go ahead and start with the very general idea of what a permutation is by reminding you of an operation that we've talked about a little bit in class, but you probably knew before you came into the course, and that is the idea of the factorial. So I have a collection here of boxes. They're all supposed to be different colors, so they're distinct from one another. And let's suppose that in total there are n items in the box, n boxes among this group. So there's n total items. Get the right color here. All right, so there are n total items. Now, because of there being n total items, one of the things you know about the factorial is that n factorial represents the number of ways to arrange any n items, to arrange n distinct items. At least you should remember that. Here's the question, though. How many ways are there just to take maybe less than n, say r total items? So the question I want to pose is, how many ways are there to arrange r less than n, so any number r, total items? Well, if we look at the items that we have above, one of the things we might think of is, okay, let's select a part of this. So the green represents our r chosen items. And if we choose r items, then that means how many are going to be left over? Well, that's this other group over here, which consists of, if there's n total and we've chosen r, this is n minus r unchosen. Now, if you think about n factorial for a second, if I was to take all of the items, there would be n factorial would be the number of ways that I could rearrange them. But choosing just r items leads to r factorial. Ways to rearrange just those items. Well, if there's r factorial ways to rearrange just those items, then how many ways are there to rearrange the unchosen items? Well, you might have guessed it. There's n minus r factorial ways to rearrange those. So the question is, how many ways are there to arrange the r items where I could choose any r I wanted to? Well, it's a little bit complicated, but you think of it this way. You think of it as starting with n factorial, which is everything, and you divide by n minus r factorial, which we know is the unchosen. Now, when you think of these unchosen items, what you're thinking of is not ordering them, choosing to leave them unordered. So if I'm choosing to order r items, then I'm choosing to not order n minus r, so I need to take away that n minus r unorderings from the n. This leads to what is called our permutation formula. And in fact, the notation here that we use in class is PNR is equal to n factorial over n minus r factorial. So this is called an R permutation. Let's look at a simple example that makes use of this notation. So the question I want to ask here is, how many 5 permutations are there on a set of 8 elements? All right, if I'm dealing with a set of 8 elements, then my n is 8. Remember, this is the total number of items. Well, the question is, what is R? If you look, I've called it a 5 permutation for a reason. This is because in general we call these R permutations. So in this case, R is 5. All right, if we use the formula that we have, what we're being asked to find then is P 8, 5, which is 8 factorial over 8 minus 5 factorial. Now we're going to be dealing with lots of calculations that look exactly like this in the course, dealing with counting, especially when we do permutations and later on combinations. It's 8 factorial on the bottom, and then you have 8 minus 5, so it would be 3 factorial in the denominator. And we should know how to calculate that answer. So our calculation over here should go as follows. 8 factorial over 5 factorial is 8 factorial over 3 factorial, which is 8 times 7 times 6, all the way down to 1. And then in the bottom, 3 factorial is 3 times 2 times 1. What we immediately notice is that the 3, 2, and 1 are on both the top and the bottom, so we can leave those crossed out. And that leaves us with 8, 7, 6, 5, 4. Now, this should be awfully reminiscent of something that we just got through doing, and that is slot diagrams. So let's think of it this way. I'm choosing, since it's a 5 permutation, I'm choosing 5 elements to make up my list or my arrangement. How many choices do I have for the first one? Well, I've got 8 because there's 8 total elements I'm picking from, which leaves 7 to be put in second place, 6, 5, 4, and so on. So the slot diagrams can also be used when thinking about a permutation. So that's something to keep in mind as you're working through these examples. If you were to calculate this and multiply this through, the answer you would get is 6,720. Now, these numbers are sort of small, so that's a pretty easy thing to do, but in general, this is not an easy task to calculate these, and so we use our calculator's help. Let me go ahead and bring up the calculator now. And so let me just remind you, this is the Math Studio app that we're using in class. Let me remind you where to look to find the number to calculate permutations. If you go to your catalog, it'll give you a lot of things to search for, but if you search for NPR, so the catalog has all the functions that are in the calculator. If you search for NPR, this brings up the NPR, which is items number. You see how to enter it in there. So for this particular example, it would be NPR 8, comma, the comma's down here in the bottom, 5. In that example, it gives us 6,720, just like doing it by hand. Now you need to be familiar with both ways of doing this. You obviously need to be able to use your calculator to do it quickly and efficiently, but it's worthwhile to learn how to calculate these by hand also. So you need to be able to concentrate on doing it this way as well. So this is just a quick introduction to the idea of a permutation, sort of what's involved with it and what the formula looks like, and then how to calculate it using your calculator. This is one of the more important topics here from the first part of the semester, so you're really going to want to pay attention to this one because it's going to show up in several different places over the course of the next couple of weeks. Thank you for watching this podcast.